Hi everybody, time for Regents Review number 10. Number 1, Rhonda has $1.35 in nickels and dimes in her pocket. If she has 6 more dimes than nickels, which equation can be used to determine X, the number of nickels she has? So we know we always start these problems with let statements, and this is telling you what nickels is going to be. So normally we would say nickels equals N, but this is telling you that nickels is X. And so then we can just let dimes equal D for now. It says here she has 6 more dimes than nickels though. So this is actually telling you that the number of dimes is the amount of nickels, which is X, plus 6. So I have X plus 6 for the dimes, and then I have X for the nickels. We know that a nickel is 5 cents. So we've got option 2 that has 0.05x. And we know that a dime is 10 cents. So we have option 2 that says 0.10 times x plus 6. So those two both line up with what we have in our question. So that means our answer is 2. 1 is wrong because that says 0.05 times x plus 6. The x plus 6 represents the dimes though. And we know a dime is not 5 cents. Number 3 is wrong because it's simply just saying, hey, there's 5 cents, and not actually assigning any variable to it. And number 4 is wrong because it's saying that a dime, because like I said, we know that dime is x plus 6, it's saying a dime is 15 cents. That doesn't make any sense. Number 2. The width of a rectangle is 3 less than twice the length, x. So again, this is telling us one of our letters. So we're going to let length equal x. And we'll let the width equal w for now. If the area of the rectangle is 43 square feet, which equation can be used to find the length in feet? So it's telling you right here that the width is 3 less than twice the length. So my W is actually equal to 3 less than, which means minus 3. And we're subtracting 3 from twice the length. Twice means times 2. And I'm multiplying the length times 2, which our length is x. So that means 2x. We know that area is when you multiply the length times the width. So our length times our width, well, that's x times 2x minus 3. And it's telling you that that area is 43. So we need something that says x times 2x minus 3 equals 43, which is choice 4. Number 3, which value of x is in the solution set of 4/3 x plus 5 is less than 17? I'm going to start by rewriting this. The first thing I'm going to want to do is get x by itself by subtracting the 5. So I'm left with 4/3 x is less than 12. Next thing I'm going to want to do is multiply by the reciprocal of 4/3, or you could divide both sides by 4/3. Either way, you're going to get the same answer. The reciprocal of 4/3 is 3/4. So if I multiply both sides by 3/4, my 4's and my 3's cancel, leaving me with x. And then 12 times 3 divided by 4 is 9. So this is x is less than 9. Notice this does not say x equals 9. It says x is less than 9. So if we look at all 4 of our options, the only number that is less than 9 is 8. So our answer is A. Number 4. If 3ax plus b equals c, then x equals, well, we need to get x by itself. So just as if these were numbers, you're going to do the opposite operations. So I'm going to move the b to the other side. Since it's plus b, your opposite is minus b. So I get 3ax equals c minus b. Remember, these questions are actually easier because you're not even doing actual calculations. So next up, I've got 3ax. Those are all touching, which means they're all being multiplied, and the opposite of multiplication is division. So I'm going to divide both sides by 3a, leaving me with x equals c minus b over 3a. Number 5, circle all the ordered pairs x, y that are solutions to the equation 4x minus y equals 10. So first thing I'm going to want to do is get y by itself. So I'm going to subtract away the 4x. So I get negative y equals 10 minus 4x. Then I have to divide by the negative 1. So I get y equals negative 10 plus 4x. So there are two ways you could do this problem. You can plug in all of these points for x and y, because remember ordered pairs are x and then y, and see if the left side of your equation equals the right side. So I'll give you an example. So if y is 2 and 3 is x, I'll have y equals, so that's here, so 3 equals negative 10 plus 4 times x, which is 3. So I plug in my numbers and then I do some math and see if the left side equals the right side. So let's do that. 3 equals negative 10 plus 4 times 3 is 12. Negative 10 plus 12 is 2. Well, since 3 does not equal 2, that makes the point 3, 2 not a solution, so you can cross that out. So you could do that for all of these points, but that's going to take a lot of time. So I'm going to show you how else we could do that, and that's by using y equals in our calculator. So if we go to y equals and type in negative 10 plus 4x, so negative 10 plus 4x, and I go second graph, so go to our table. These are all of the points that are solutions. So this is a little more difficult because I can't have the paper next to me and the calculator at the same time, so I'm going to have to keep flipping back and forth here. But let's see, we have 2, 3, and if I go to my calculator, I have the point 2, negative 2. So that's not right, so we can eliminate that. I have the point negative 1, negative 14. So if I go to my calculator, I have the point negative 1, negative 14 right there. So we can circle that. Then I have 0, 0. 0 is actually negative 10 on my calculator, so that's crossed off. I have 1, negative 6. 1, negative 6 is right there, so that gets circled. 5, 10. 5, 10 is right there, so that gets circled. 0, negative 10. 0, negative 10 is right there, so that gets circled. 3, 4. I have 3, 2, so that gets crossed off. 6, 0. I have 6, 14, so that gets crossed off. And then finally 4, negative 1. I have 4, 6, so that gets crossed off. So clearly doing it the calculator way is way, way faster than when I showed you how to do it by hand over here. Okay, we've got one more question on the back. Number 6. 4 relations are shown below. We've got 1, 2, 3, and 4. State which relations are functions. Okay, so for our graph, we tell if something's a function by doing the vertical line test. So I'm drawing a vertical line. It only crosses one time there because that's an open circle. But if I do my vertical line here, it crosses twice. So this is not a function. And let's write because it fails VLT. So 1 is not a function because it fails VLT. We can change these to normal numbers. We don't need Roman numerals. For number 2, we have a set of points. We need to look at our x values and see if we have any repeating x values. So I have 1, 2, 3, 2, 1. I have 2 1s and 2 2s. So 2 is not a function because there are repeating x values. Number 3, same thing, except we have a table, so we just need to look to see if I have any repeating x values on my table. Negative 4, 0, 4, 6. None of those repeat, so 3 is a function. And number 4, y equals x squared. Well, we just need to graph that and see if it passes the vertical line test. So if I go to my calculator, go to y equals, switch this to x squared, and hit graph, we see our graph. It does pass the vertical line test. Nowhere does it cross twice when you draw a vertical line. So 4 is a function. So the question, state which relations are functions. The answer is 3 and 4, or 3 and 4. And then it says, explain why the others are not functions. Well, we wrote it up here. 1 is not because it fails the VLT. 2 is not because there are repeating x values. And that's it.